Okay, let's do this problem. We're asked to find the points on the given curve where the tangent is horizontal or vertical. And then we get to assume that we're only going to go from 0 to pi, and our function r is equal to 8 cosine theta. So remember that our dy dx is going to be given by the derivative with respect to derivative of y with respect to t, or theta, derivative x with respect to t or theta. So let's figure out our x values. So given this, it's going to be r cosine theta, so it's going to be 8 cosine theta times cosine theta. And then y is going to be 8 cosine theta times sine theta. So it's the r cosine theta, r sine theta business. And then we need derivatives of each of them. So the first one, or the numerator for our derivative, is going to be the y prime. So we're going to need to do a product rule. It's a product. So it's going to be 8. The derivative of cosine is negative sine, so negative 8 sine theta. So the first times the second, plus or derivative first times the second plus the first times the derivative of second. Okay, so I think we can simplify that. We can factor out an 8, and then we're going to get a negative sine squared theta plus cosine squared theta. Unfortunately, that's not equal to 1. So that's a numerator. The denominator will be x prime, and that's going to be the derivative of the first times the second. So it's going to be derivative of the first is going to be negative 8 sine theta times the second cosine theta plus the first 8 cosine theta times the derivative of the second, which is also cosine theta, or sine. So derivative first times second plus the first times the derivative of second, so this is negative sine. So the denominator would be negative negative, so that's negative 16 times, because we're adding the same thing, sine theta cosine theta. Okay. All right, so those are constants that are sitting outside. We don't need to worry about them too much. We're going to be concerned about this thing being, when the numerator is equal to 0, we have horizontal tangent. When numerator is 0 and vertical tangent when denominator equals 0. So let's look at the horizontal tangents first. And we're going to set the numerator equal to 0. So minus sine squared theta plus cosine squared theta is equal to 0. We need to remember our trig a little bit. And so I think this is going to just be cosine squared theta equal to positive sine squared theta. And they're both positive, so we take the square root. Cosine theta equals plus or minus sine theta. And the sine and cosine are equal to each other at pi over 4. And possibly 3 pi over 4 also. So at those two places, pi over 4 and 3 pi over 4, we're going to have, and we only need to go from 0 to pi. So I think that's those are our solutions. And then we would plug this into the function to get our values. So r when you put pi over 4 in, you'll get 8 times cosine pi over 4, which is pi over 4 is root 2 over 2. That would be 4 root 2. And r of 3 pi over 4 is 8 cosine of 3 pi over 4. And this is negative root 2 over 2. This is 4 root 2 with a negative. Okay, so how would we see that in the graph? I think in the graph we have the radial. Let me fix up my graph a little bit. And let me squeeze it in here, since I think I'm gonna want that space to actually draw it. So pi over 4 is this ray over here, and it's gonna have a radial distance of 4 root 2, whatever that distance is. I would be at this point. And then 3 pi over 4 is over here, but then I'm looking at a negative value, so my negative value would be over here somewhere. So these are going to be my 2 points. We haven't even drawn the graph yet, but if we were to draw the graph at these points, we will have a horizontal tangent line. All right, let's take a look at the vertical side. We're going to set the denominator equal to 0. We're going to say sine theta times cosine theta equals 0. So that means either sine is equal to 0, which means theta is equal to 0 or pi. So those are at the endpoints. Or cosine theta is equal to 0. That means theta is equal to pi over 2. 3 pi over 2. I guess we don't need to worry about 3 pi over 2 because 3 pi over 2 is not between 0 and pi, so we don't need to worry about that. Okay. So when does that happen? Let's put in these values into the r function. R of 0 is 8 cosine 0. And what is that? That will get us a 0 angle would be this, and then 8 would be somewhere over here maybe. R not equals 0, r of 0, r of pi is going to be 8 cosine of pi. Cosine of pi is negative 1, so this is negative 8. So if you're pointing this way, it looks like you're at the same point. So it looks like 0 and pi give us the same r value. Now let's put in pi over 2, r of pi over 2, and we know that cosine pi over 2 is 0. That's how we got this in the first place, so that by the time we get to pi over 2, you're going to be at 0. Okay? So if we haven't already figured out through our lecture exercises and those slides, this cosine theta, 8 cosine theta, is going to be a circle to the right of it's going to be a circle to the right of the y-axis. Now instead of having this inferior drawing, we can actually just go to Desmos and graph it. So r equals 8 cosine theta, and this is that circle that we were talking about. And let's again convert this into parametric equations. And then let's change the t's into some parameter values a. Doesn't look like it's taking it. Um, Maybe put parentheses around here. There it goes. Didn't like something. So if I go around here, it looks like it's going pretty fast. So if I limit this to go from 0 to pi, and I can see it. If I start at 0, I'm starting at this point 8, and then if I move along, by the time I get to, it looks like pi over 2, I'm over here, and by the time I get to pi, I'm over here. So remember those theta values that gave us the points? We had some points at pi over 4. So we're up here. That's one of the horizontal tangents. And then the other one is 3 pi over 4. So let me put the 3's here. And there's my other point. And then just so you know, it's actually the distance from the origin to this point is that 4 root 2 business that we got. And then the other points are when theta is equal to 0 and pi over 2. So let me do the 0 first. Let's put zeros in here. And then that's over here at this point. And that's looks like there's a vertical asymptote, and then or a vertical tangent line, and then the other one is going to be when this is pi over 2. And then that last one, pi over 2. So there's that last point at 0, 0. So these are our, this is our graph, and these are the places where we have our horizontal and our vertical tangents. Okay. All right. I hope that helps, and good luck.